So here we've got another problem, quite similar to the one that we did in the previous video, but of course the shapes that are used here is different. The figures or whatever the closed objects used are cone and a sphere here. Last time it was sphere and a cylinder. So what we've got here is a right circular cone is of height 8.4 centimeters and the radius of its base is 2.1 centimeter. It is melted and recast into the sphere. Find the radius of the sphere. So again, the concept is exactly the same, all right? See, when you change something, say for example, when you change a cube into a sphere, or say when you change a cuboid, or say a cube into a cone, the one thing is sure, the volume is the same. You're not taking away any of the, the material used in this cube. You're not taking it or you're not adding it to make this cone. The same amount of quantity, the same quantity of the thing is what you're going to use to make this. So when you do that, the volume is going to be exactly the same, right? The volume is not going to change at all. The volume is exactly going to be the same. So all you have to do is eventually equate the volume, see the unknown thing that may be, height or radius or whatever that is, and then find it. That's all you have to do. So coming back to this problem, we've got the radius given as 2.1 centimeters. So we've got R as 2.1 centimeter as far as the cone is concerned. Then we've got the height as 8.4 centimeters. Now, this is changed into what? This is changed into a sphere. It is recast into a sphere. So the volume of a right circular cone is nothing but, okay, let me write this statement. Volume of right circular cone equals volume of the sphere, right? So the volume of the right circular cone is nothing but 1 by 3 pi r square h. And the volume of the sphere is 4 by 3 pi r cube. Now notice that this radius is not equal to this radius. So that's why I've written a smaller r here and a capital R here. So now we've got the volumes of the right circular cone equal to the volume of the sphere, right? Because of the metal, the same amount of the material is used to make make the sphere from the cone. So yeah, so this is just an example. What we're doing here is actually a cone transformed to a sphere, all right? Cone to sphere. So the volume is going to be same. So here we've equated it. So let us substitute the values. Now 1 by 3 times 22 by 7. Pi is 22 by 7 and the radius of the cone is given as 2.1. So 2.1 the whole square into the height is given as 8.4 equals 4 by 3 times pi is 22 by 7 times the radius is what we have to find the sphere. So therefore it remains unknown. So let us solve that here. So let me rewrite that here so that it will be easy to solve. 1 by 3 times 22 by 7 times 2.1 times 2.1 times 8.4 equals 4 by 3 times 22 by 7 times r cube. So now 22 by 7 gets cancelled and 1 by 3 and 1 by 3 gets cancelled. 1 by 3 into 4 is 4 by 3. So I'm just taking out 1 by 3 there. So 1 by 3 and 1 by 3 gets cancelled here. Or I'll just show you what I did there exactly. All right, so say you got 1 by 3 and into something equals 4 by 3 into something. I can write 4 by 3 as 4 times 1 by 3. So this 1 by 3 and this 1 by 3 gets cancelled, right? Or if you shift this 1 by 3 to that side, it becomes 3 by 1. Anyways, it gets cancelled. So that's why even before shifting it, you can cancel the same terms on both the sides of the equal to sign. So you're left with now 4 goes 2.1 times and 8.4. So all we are left with is r cube equals 2.1 times 2.1 times 2.1, which is nothing but r cube equals 2.1 the whole cube. So therefore the radius is 2.1 centimeter. So the radius of the sphere is just the same as the right circular cone here. So the radius of the sphere is found to be 2.1 centimeter. So this ends this problem. So that's all. It's a pretty simple problem. So as I've told you, if something is recast into something, the first thing that has to come to your mind is that the volume is exactly the same. So you can straight away equate the volumes of both the things that we're talking about. maybe a sphere into a cone, or cone into a sphere into a cube, whatever that may be. The volumes are going to be same, and you just have to figure out the unknown stuff here. Here it was r, it could be h, it could be small r, or whatever that is. So that's all that there is to do as far as this problem is concerned. So I'll see you in the forthcoming videos with more problems based on surface areas and volumes.